Okay, so why did we need logarithms? Why were logarithms much more important? So, um, so the question was, you had a question like 2x equals 8. You said, that's fine, right? I can figure that out through change the base at 2 to the x equals 2 to the third, and x equals 3. And then the next question might have been, I might have asked you, for example, like, I don't know, like 27 to the 2 minus x equals 9 to the 3x plus 1. Um, yeah, and so, you'd be like, okay, Mr. Rudd, I can figure this out. I can turn everything to the base 3, and you're like, 3 to the third times 2 minus x equals 3 squared, 3x plus 1. And so you got 3 to the 6 minus 3x equals 3 to the 6x plus 2. I think everything's fine. Sometimes I make mistakes. Send me a link. Tell me so. And so we know the bases are the same. So 6 minus 3x equals 6x plus 2. 9x equals 4. So x equals 4 over 9. And you can check that in, and you can see it works. Or you can use Desmos. You can use MSolver in your calculator. Or you can use Desmos, and that's fine. But the next thing was, let's say I give you this equation, and I say, 2x equals 12. Now you have a problem here because we had equations like this. For example, imagine a story like, one bacteria doubles every hour. And the question is, theoretically, when are there 12 bacteria? And so you're thinking, well, how do we solve this? Because 12 is not a power of 2. My question to you is, does this exist? Do we bother to solve this problem? Anybody? So you say, yeah, there is an answer to that. Well, first of all, how do we show that there's an answer to that? Because if there's no answer, we have other things to do in our lives. So I want you to think about this for 30 seconds. Come up with some type of explanation of how do you know there is a solution to this. It might not be the prettiest answer, but there is a solution. Okay, well, my idea, in our ideal classroom, we would be sharing the answer, so I'll lay it out. We know that, 2 to the third equals 8, and I know that 2 to the fourth equals 16, which means I know that 2 to the something equals 12. Therefore, we know that x is between 3 and 4. Now, so you say, well, Mr. How do we get this out? Well, that's what logarithms are for. And last year, you learned about how to solve this, how to get the x's down. But the problem is, you don't really need that anymore, because if you had a question like this is going to be on a part 2 question, and you're going to have a calculator. When I went to school, we didn't get a calculator. We had or maybe a scientific calculator. We had tables. And then it was only in 2000 that New York State let the kids have scientific calculators. And so now, you can actually put it and solve. You can actually have your calculator solve this. And now, nowadays, so it also if you look at your calculator, you notice there's a special button for log and ln. So base 10 was important and base e was important, and so you still have to deal with that. But now the calculators allow you to transform this into this. Actually put this expression in the calculator, and now you just solve it on your own. So the question is, why do we have to do this? So these are holdover rules. IB still likes to ask it. Once again, the calculator does all this for you. You don't need logarithms, but how do we do it? Well, there's 3 rules you can use back in the old days. There's 3 rules. So what I'd like you to do first is, just to refresh your memory, I'd like you just to, do log of 2 plus log of 5, and then I want you to do in your calculator log of 10. You can pick, just do any log, and it can be any base, actually. So you can pick log 10, the log of it. You can pick ln, which is log e. You can actually, figure out how to, your calculator can do this and pick any log you want. So we know the log is 10. And so does this hold? What rule do you think applies? Let's try another one. How about log b 16 minus log b of 8, and then I want you to do the next one, log b of 2. What rule comes up then? So